To predict or explain, that is correlation. A presentation on correlation and prediction design for the Interamerican University of Puerto Rico, Ponce Campus, by Carlos A. Robles Carrero. So, what is correlation? A correlation is when there are visible patterns in the data. Having this in mind, a correlational research is when you observe patterns to predict scores or explain relationship amongst them. This type of research is a non-experimental research where these variables can be measured and statistical relationship can be assessed. Now that we know what is it, we're going to see a correlational history and how it developed. In the late 19th century, unknown statisticians began developing procedures to calculate statistic correlations. On November 1895, Carl Pearson presented to the Royal Society of England the correlation of formulas we know today. In 1897, a student of Pearson, called Ewell, developed solutions for correlating 2, 3, and even 4 variables, expanding what Carl Pearson did in 1895. In 1904, Spearman published his ideas about the correlational matrix to display coefficients and formulas for data that did not show a belt distribution. In 1935, Fisher pioneered the testing and analysis of variances. Following that, in 1963, Campbell and Stanley provided the paper in which they spoke of the experimental and quasi-experimental design. In the 70s and 80s, the advent of computers improved ways to measure complex scales and other studies. Today, researchers test elaborate models containing many more variables. And what is correlational research used for? It is used when you seek to relate 2 or more variables to see if they influence each other. These correlations can be designed as predictive or explanations, but both design seeks to see a correlation between the variables. Prediction design has most of the same functions as explanatory design with a few minor changes. In prediction design, normally the term explanatory and response variables are not used. Rather, it has predictors and outcome variables as terms. This is because this research is trying to predict and not explain. Another difference is that prediction design is focused on determining future results or forecasting. For example, if we are using exercise to predict age, we can develop an equation that allows us to determine a person's age based on how much they exercise or vice versa. Of course, no model is 100% accurate, but a good model can be useful even if it's wrong at times. What both designs have in common is the use of R and R squared and the analysis of strength of the relationship among the variables. The prediction design uses variables as predictors to anticipate outcomes. The variable that predicts the outcome is called a criterion. Researchers identify the variables that predict or forecast a criterion. For example, a research might find that college GPA ratings provided in an interview and the rating found in a reference can predict the effectiveness of a teacher in the classroom. We could state, using this information, that the criterion is teaching effectiveness, and the predictor variables are the GPA, the interview ratings, and the reference ratings. In this slide, we can see simple characteristics to identify a prediction design. The first one, the author typically includes the word prediction in the title. Then we see that they measured the predictor variables at one point in time and the criterion variables at a later point in time. And we could also see that the authors forecast future performances. Other characteristics you will find in predictive design is that scores are displayed in 2 types of graphs. Scatter plots, which contains the data in dots that are scattered in the graph, and a correlational matrix, which is a simple matrix table. Another characteristic is that the scores are associated. When you associate them, there are 3 possible outcomes. The positive correlation. In this type of correlation, both variables increase or decrease at the same time. A correlation coefficient close to +1 indicates a strong positive correlation. Then we have the negative correlation. This type of correlation indicates that as the amount of one variable increases, the other decreases, and vice versa. A correlation coefficient close to -1 indicates a strong negative correlation. We have another one, no correlation. This indicates no relationship between the two variables. A correlation coefficient of 0 indicates no correlation. And finally, these associations can explain partial correlation and multiple correlation. There are 6 steps to follow when conducting a correlational study. Firstly, determine if the correlational study is the best research for this situation. Secondly, identify or choose the individuals to be studied. Then, identify 2 or more measures for each individual in the study. Fourthly, collect the data and be attentive to potential threats that might appear in the investigation. Fifthly, analyze the data. And finally, interpret the results. One of the advantages of research is that it permits simultaneous study of several variables, but the researcher must be careful not to do a shotgun approach. This approach means an inappropriate use of adding many variables in hope that some of the variables will indicate a relationship. Correlational research is widely used and appears to be simple, straightforward indices of relationship. There are, however, several limitations with the use of correlation that need to be understood fully. One that is most concerning is the overinterpretation, making it too much of a measured relationship and thinking that they are 100% accurate. In this slide, we're going to see a video. This is an example in a correlational research. You'll find 2 sets of dancers, the red group and the black group. They will demonstrate a visual representation of positive, negative, and no correlation in a research. As you can see in the video, there are 3 sets in 2 groups. The ones in the back, the ones in the middle, and the ones in the front. Do you see a correlation? As you can see, this is a positive correlation because they are synchronous. They're doing the same movements in each other. So we could say this is a +1. This is the R that we mentioned earlier. Now, in this next section of the video, see that they're doing the same thing, but is the movements being caused by the other group, or is it that they are correlation? As demonstrated here, correlation does not imply causation. It simply measures changes in variables. This research just measures that. Now let's see another section of the dance. See if there are any correlation. Are they doing the same thing? Are they doing the opposite? What are they doing? Did you figure it out? In this section of the video, the dancers did not correspond to each other, so this is a correlation of 0. The changes did not have a correlation between each other. And now, this is the final video that you're going to see. See if you can find if there are correlations here. There are 2 in the back, in the middle, and in the front. As you can see, the 2 in the back, one is moving back and forward slowly, the other one is quickly doing it. In the middle, one is trying to be higher, the other one is trying to be lower. And in the front, one is bending forward and the other one is bending backwards. So what type of correlation do you think it is? As mentioned here, this is a negative correlation. as expressed in the R as a -1. So this is negative correlation. And this is the presentation. Thank you very much for your time.